You're about to see something that breaks the pattern. His 3i Atlas shifts from the orbit and the new Hubble images of 3i Atlas have arrived, and what they show isn't just another anomaly to add to the growing list, isn't just one more feature that doesn't quite fit comfortable natural explanations. What these images reveal is structure, organisation, symmetry. And those three words, when you're talking about objects that are supposed to be chaotic fragments of ice and rock tumbling through space, create cognitive dissonance that demands resolution. Because nature doesn't do symmetry casually, doesn't create balanced patterns through random processes, doesn't organise itself into configurations that look designed unless there's mechanism creating that organisation. And we need to figure out what that mechanism is before we can claim we understand what we're actually looking at. The images themselves are stark. Please hit like and subscribe if you like this sleepy explanation. Now, are processed through filters specifically designed to reveal faint structures that would otherwise be invisible against the bright glare of the central nucleus. The Larsen-Cikanina rotation gradient filter does exactly what its technical name suggests, enhances gradients in the rotation average brightness distribution to make directional features stand out. Without this processing, without the careful analytical work that separates signal from noise and that highlights patterns hidden in the raw data, you'd see fuzzy blob. Bright centre surrounded by diffuse glow. Nothing obviously unusual. Nothing that would make you stop and question whether you're looking at natural object or something else entirely. But apply the filter. Process the images properly. Remove the overwhelming brightness of the central coma that obscures fainter features, and suddenly you see them, two jets, extending outward from the nucleus on opposite sides, balanced, symmetric, mirror images of each other stretching into space with clarity that makes their reality undeniable. Not artifacts, not processing glitches, not random fluctuations in the data that happen to create illusion of pattern. Real structures, physical flows of material emanating from specific regions on the object's surface and maintaining coherence across distances that make them visible in images where the nucleus itself is barely resolved. Before we go deeper, before we examine what this symmetry means and why it matters and what explanations might account for it, you need to hit that subscribe button right now. Because what we're documenting here isn't just interesting space news, isn't just another story about unusual comet or mysterious visitor. This is real-time analysis of observations that are accumulating faster than the scientific community can process them, that are revealing patterns that challenge fundamental assumptions about what natural objects can do. And if you want to follow this investigation as it develops, as each new image and each new measurement adds pieces to a puzzle, we're only beginning to see the shape of "you need to be here." Hit subscribe, enable notifications. Give this video a like because engagement helps the algorithm show this to other people who care about these questions. This matters too much to let it disappear into the noise. The timeline of observations creates context, because the symmetric jet structure isn't something that appeared suddenly in the most recent images, wasn't absent in earlier observations and then spontaneously manifested. Instead, it's been there all along, has been visible in data from July 21st, 2025, the time frame when 3i Atlas was first being characterized intensively after detection, was present in images from November 30th, 2025, persists in the December 27th, 2025 observations, multiple dates, multiple observation campaigns. Consistent pattern showing that this isn't transient feature that came and went, but is instead stable characteristic of how this object behaves. That stability is significant, because cometary jets are typically variable, come and go as surface regions rotate in and out of sunlight, change in intensity and direction as sublimation rates fluctuate with solar heating, show evolution over timescales of hours to days as the object rotates and as different ice patches become active or dormant. Seeing jet structure that persists for months, that maintains symmetric configuration across observation campaigns separated by weeks, that doesn't show the kind of chaos and variation that normal cometary activity produces, is immediately notable, is signature of something operating with stability that random natural processes don't typically achieve. The July images established the baseline, showed that yes, even in early observations when the object was first being studied in detail, the symmetric pattern was already present, was already visible to anyone looking carefully at the processed data. But looking carefully is doing heavy lifting in that sentence because the features are faint. require the gradient filter enhancement to stand out clearly, require knowing what you're looking for and how to extract it from data that contains enormous amounts of information, most of which isn't relevant to this particular question. So the early reports focused on the anti-tail, focused on the dramatic sunward-pointing structure that dominated the large-scale appearance, and that was obvious even without specialized processing. The symmetric jets were noticed by researchers analyzing the data in detail, but didn't get the same public attention because they were more subtle, were features that required explanation and interpretation rather than being immediately visually dramatic. But they were there, were documented, were part of the observational record even if they weren't part of the narrative that most people following 3I Atlas were hearing about. November and December observations confirmed that the pattern persists, that the symmetric jets aren't transient, aren't artifacts of specific viewing geometry or specific instrumental settings that might create illusions that disappear when you observe from different angle or with different configuration. Instead, they show up consistently, maintain their bilateral arrangement, continue exhibiting the balance and organization that makes them anomalous compared to what we expect from natural cometary activity. And now, with multiple observation dates all showing the same features, with the pattern confirmed beyond doubt as real physical structures rather than processing artifacts or coincidental alignments, the question shifts from are they real to what creates them? Because they're definitely real. The data is unambiguous. Multiple independent observations using rigorous processing methodology that's been validated on countless other comets all confirm that yes, 3I Atlas is exhibiting symmetric bilateral jet structure. So the reality is established. The explanation is what we need to develop. The visual appearance is what first catches attention. Because even in processed images, even when you're looking at data that's been filtered and enhanced and optimized for revealing faint structures, the symmetry jumps out. Isn't subtle pattern that requires careful measurement to detect. Is obvious visual feature that your brain recognizes immediately as organized rather than random. Two features, extending from central nucleus, opposite directions, balanced lengths and intensities, mirror image configuration that looks like it was planned rather than like it emerged from chaos. And looks like it was planned is exactly the cognitive alarm that makes this significant, because we're pattern recognition machines. Our brains are wired to detect organization in our environment, to distinguish between random noise and structured signals, to recognize when something shows characteristics that indicate intentional design versus accidental formation, and symmetric bilateral patterns trigger those recognition circuits strongly, make us see purpose, make us infer agency or mechanism, creating the pattern rather than accepting it as coincidental arrangement. That inference isn't proof of anything, isn't evidence that the jets are actually designed or that 3I Atlas is artificial. Human tendency to see patterns and to attribute them to intentional causes is well-documented cognitive bias. We see faces in clouds, find animals in random star patterns, detect conspiracies in random coincidences. So the fact that the jet structure looks organized doesn't automatically mean it is organized through anything beyond natural processes. Might just be triggering our pattern recognition instincts without actually representing the kind of organization those instincts evolved to detect. But it also might be real organization, might be pattern that exists not because our brains want to see patterns, but because physical processes are actually creating structured output. And distinguishing between false pattern recognition and accurate detection of real structure is exactly what scientific analysis is designed to do. You don't just trust your instincts, you measure, you quantify, you determine whether the pattern is statistically significant or whether it could arise from random processes with probability high enough that you shouldn't be surprised to see it occasionally. The measurements confirm the visual impression. The jets are symmetric within measurement uncertainty, extend to similar distances from the nucleus on both sides, show comparable brightness and structural characteristics, maintain mirror image configuration across multiple observation dates. This isn't approximate symmetry that you could explain through cherry-picking viewing angles or through loose interpretation of what symmetric means. Is quantitative correspondence that survives rigorous analysis and that indicates the two jets are genuinely balanced rather than just happening to look balanced from specific perspective. The angular spacing is what makes the pattern even more remarkable, because it's not just that there are two jets on opposite sides. That could potentially happen if you had active regions at opposite poles of a rotating nucleus, and if both regions happen to be emitting simultaneously. Unusual but not impossible through natural processes, but the detailed analysis shows that the jet arrangement includes a third component, shows that there's not just bilateral symmetry, but threefold symmetric structure where jets are spaced at roughly 120-degree intervals around the nucleus. 120 degrees, 3 jets, threefold rotational symmetry. Exactly the spacing you'd get if you were deliberately arranging 3 identical features around a central point and wanted them equally distributed. Divide 360 degrees by 3 and you get 120. That's the geometric relationship. That's the mathematical pattern. And seeing it in physical structures emanating from nucleus that's supposed to be a regular chunk of ice and rock is jarring because threefold symmetry with precise angular spacing is not what natural fragmentation and random ice distribution typically produces. We've studied hundreds of comets, have detailed observations of dozens showing jets and active regions and surface features, and the pattern is always chaos, is always irregularity, is always asymmetric arrangements where jets point in whatever directions happen to be determined by where ice patches ended up during formation and how the object has been modified by previous passages near stars or by collisions or by any of the random processes that shape small bodies. Threefold symmetry isn't in that catalogue, isn't something we've seen before, isn't what the natural comet model predicts or what previous observations of natural objects have prepared us to expect. But we're seeing it on 3I Atlas. The processed Hubble images show it clearly. 3 jets spaced at 120-degree intervals creating symmetric pattern that persists across multiple observation dates, and that pattern demands explanation because it's not random, is organised in ways that natural processes don't typically create, is structure rather than chaos, and structure implies mechanism, implies something creating the organisation rather than just accepting whatever random configuration happened to result from natural formation and evolution. The comparison to 2I Borisov is instructive, because Borisov was the second confirmed interstellar visitor, was studied extensively during its passage through the solar system in 2019, showed clear cometary activity with visible coma and tails created through normal sublimation of volatile ices, was in many ways exactly what we expected an interstellar comet to look like, and importantly for current discussion, Borisov's jets were completely chaotic, were messy, were irregular, showed the kind of random asymmetric patterns that we associate with natural cometary activity, where ice patches sublimate wherever they happen to be located, and create jets pointing in whatever directions the local surface geometry determines. Borisov fit the natural model perfectly, validated our understanding of how comets behave, demonstrated that yes, interstellar comets can look and act just like solar system comets, because the physics is the same regardless of where the object formed. Sublimation works the same way everywhere. Solar heating creates the same responses. The activity patterns are recognizable and explicable through conventional framework. 3I Atlas doesn't fit that model, shows behavior that distinguishes it from Borisov and from every solar system comet we've studied. The anti-tail pointing sunward rather than away. The narrow coherent jet structure maintained over enormous distances. The rotation locked with unusual alignment to the sun, the gas velocities that are too slow for natural sublimation, and now the symmetric threefold jet pattern that looks organised rather than chaotic. Each anomaly individually might be explicable through exotic but natural processes, but the accumulation of anomalies, the pattern where everything about 3I Atlas differs from what normal comets show, creates cumulative case that the natural explanation is becoming increasingly strained, and the symmetric jets add weight to that cumulative case, because they're not isolated curiosity, aren't unconnected feature that happens to be unusual but that doesn't relate to the other anomalies. Instead, they fit into the larger pattern, reinforce the impression that something about this object is fundamentally different from natural comets, that the organisation we're seeing in the jet structure is part of broader organisation that extends to rotation and thermal properties and trajectory behaviour and all the other features that keep showing characteristics that natural processes struggle to explain. The rotation axis alignment is what makes the symmetric jets even more significant, because we've established from previous observations that the rotation axis is aligned unusually precisely with the direction toward the Sun, that the anti-tail originates from a pole that maintains pointing toward our star with stability that requires the rotation axis to be locked into configuration that has very low probability of occurring randomly, And if the rotation axis is thus aligned, if one pole points toward the Sun consistently, then the other pole points away. Points in the opposite direction creates natural location for symmetric pair of jets if both poles are active. But that's where the threefold symmetry becomes problematic for natural explanations. Because if jets are located at the poles, you get two, north and south, opposite sides, bilateral symmetry. But you don't naturally get third jet positioned at 120 degrees unless there's something beyond just pole-based activity, unless there are active regions at non-polar latitudes that happen to be positioned such that they create symmetric pattern. And the probability of that happening randomly, of ice patches ending up at exactly the right locations to produce threefold symmetry, is small enough to raise questions about whether random formation is adequate explanation. This is the same kind of probability argument that we've encountered before, where individually any specific feature might have low probability, but not so low that you'd reject natural processes. But when you start multiplying probabilities together, when you require multiple low probability features to all align, the cumulative probability drops rapidly. Rotation axis aligned with Sun at 2% probability. 3 jets at 120-degree spacing at maybe 1% probability. Multiply them and you're down to 0.02%. 2 chances in 10,000. Still possible, still within the realm of what random chance might produce, but uncomfortable enough that you start wondering whether natural processes are really the right framework or whether you're forcing observations into a model that doesn't fit. The stability of the jet pattern over multiple observation dates is what distinguishes this from transient features that might arise temporarily through unusual but natural conditions. Because if the symmetric pattern appeared in one observation but not in others, you could argue it was coincidental alignment, lucky viewing geometry, specific combination of rotation phase and active region positions that created momentary appearance of organization. But when the pattern persists, when it's visible in July and November and December, across different viewing geometries and different instrumental configurations, coincidence becomes much less plausible explanation. Persistent pattern suggests persistent mechanism, suggests that whatever creates the symmetric jets is stable feature of how the object operates rather than random fluctuation. Natural comets show variability in their jet patterns. As the object rotates, different regions face the Sun. Some become active as they're heated, others become dormant as they rotate into shadow. The pattern of jets changes on the rotation timescale, which for 3i Atlas is roughly 16 hours. You'd expect to see jets appearing and disappearing, changing direction as rotation brings active regions to different orientations, showing evolution rather than stability, showing the kind of temporal variation that's characteristic of rotation-driven sublimation. But the symmetric pattern persists, doesn't show the expected variation, maintains configuration across timescales much longer than the rotation period, suggests that either the active regions creating the jets are extremely stable, are locked into positions that don't vary as the object rotates, or that the jets aren't created through rotation-dependent sublimation, but through some other mechanism that operates continuously regardless of rotation state. The first option requires explaining why active regions would be so stable, why ice deposits at specific locations would continue sublimating at consistent rates for months, despite rotation that should cause thermal cycles as those regions alternately face toward and away from the Sun. Thermal inertia could provide some stability, could smooth out the heating and cooling cycles, could allow sublimation to continue more uniformly than it would if surface responded instantly to illumination changes. But thermal inertia operates on timescales of hours to days, doesn't explain stability over months, doesn't provide mechanism for maintaining exact symmetric spacing of active regions through processes that should be chaotic and uneven. The second option is more problematic for natural explanations because it requires mechanism beyond sublimation, requires something that can create symmetric jets without depending on which parts of the surface are being heated by sunlight at any given moment. And that's difficult to construct from natural processes. What mechanism operates uniformly around a nucleus? What physical process creates threefold symmetric output from object that should be irregular chunk of ice and rock? The options are limited, and none of the obvious candidates work well. Internal pressure could create uniform outflow if there were pressurized gas trapped within the nucleus, and if that gas were escaping through vents at specific locations. But maintaining pressure requires containment, requires intact ice shell or solid crust that can hold gas against the pressure gradient trying to force it out, and for that shell to have vents positioned in threefold symmetric pattern requires formation process that creates that regularity, requires explaining how natural accretion or fragmentation, or any of the processes that create small bodies, would produce structure with geometric precision. Tidal forces could create symmetric stress patterns if the object were being pulled by differential gravity, could create cracks or fractures that develop preferentially at specific locations determined by the stress field. But 3I Atlas isn't in the strong tidal environment that would create significant differential forces, isn't close enough to any massive body that tidal effects would dominate structural evolution. And even if tidal forces were relevant, getting threefold symmetry rather than twofold or fourfold or some other pattern would require specific combination of object shape and tidal field geometry that seems contrived. Rotation-driven instabilities could create patterns in outflow if the centrifugal forces from spinning were strong enough to affect how material escapes, could create preferred directions determined by balance between rotation and pressure gradients. But again, getting threefold symmetry from this mechanism requires specific conditions that don't obviously arise from natural rotation of irregular bodies. And the rotation rate of 3I Atlas, while well characterized, isn't extreme, isn't fast enough that centrifugal effects dominate dynamics in ways that would overwhelm the irregularity of natural ice distribution. So the natural explanation struggle can construct scenarios, but they all require special circumstances, require specific conditions that we can't verify and that don't obviously arise from normal processes, require assuming the object has unusual properties that aren't typical of comets, but that might exist if you invoke exotic formation or evolution. Each scenario is possible in principle, but none is compellingly natural in the sense of being the obvious outcome of well-understood processes operating on typical materials, and this is where the engineering hypothesis enters, not because we want it to be true, not because alien technology is more exciting than natural phenomena, but because engineered systems naturally create symmetry, because designs optimize geometry for functional purposes, because threefold symmetric arrangement of jets is exactly what you might choose if you were building propulsion or attitude control system and wanted balanced thrust options. Because the pattern that's difficult to explain through natural processes is straightforward to explain through design. 3 thrusters spaced at 120 degrees, each capable of firing independently or in combinations to create forces in different directions, coordinated to produce net thrust along desired vector through appropriate selection of which thrusters operate and at what power levels. This is standard spacecraft architecture. Is how attitude control systems are designed when you want 3-axis control without requiring thrusters pointed in every possible direction. 3 symmetric jets give you enormous flexibility in maneuvering while minimizing the number of separate systems you need to build and maintain. The functional interpretation makes immediate sense from engineering perspective, even though it creates cognitive dissonance from natural science perspective, because we're trained to look for natural explanations first, to exhaust every possible conventional mechanism before considering alternatives that require invoking technology or intelligence. That's appropriate methodology. That's how science should work when confronting anomalies. But there's a point where insisting on natural processes despite accumulated evidence becomes less like scientific caution and more like ideological commitment, where you're defending a framework not because it fits the data, but because accepting the alternative requires confronting implications you're not ready to deal with. And the symmetric jets might be that point for 3I Atlas. Might be the observation that tips the balance from unusual but possibly natural to requires explanation beyond conventional framework. Because when you combine the jet symmetry with all the other anomalies, with the anti-tail physics that violates natural sublimation constraints, with the rotation locked to improbable alignment, with the trajectory deviations indicating thrust, with the particle deployment showing manufacturing precision, the cumulative case becomes overwhelming. Each individual feature might be explainable through exotic natural processes if you're willing to invoke enough special circumstances. But explaining all of them simultaneously through natural framework requires stacking so many special circumstances that the explanation becomes more contrived than just accepting that the object is artificial. The Larsen-Sekanina gradient filter is what makes the symmetric jets visible clearly enough to analyze quantitatively. Without this processing technique, without the careful work of removing the bright central coma and enhancing faint structures, the jets would be barely detectable if visible at all, would be lost in the glare, would be buried in noise that overwhelms subtle features, but with proper image processing, with techniques developed over decades of studying comets and optimizing methods for extracting maximum information from limited data, the structures emerge, become clear, become analyzable. This processing isn't arbitrary manipulation, isn't applying filters that can create illusions or artifacts that look like real features, but that actually result from the processing methodology itself. The Larsen-Sekanina filter has been validated extensively, has been used on hundreds of comets, has been tested to ensure it reveals genuine structures rather than creating false positives, and the validation process includes checking processed images against unprocessed data, against observations from different instruments, against theoretical models of what processing should and shouldn't be able to enhance. So when the filter reveals symmetric jets on 3I Atlas, when those jets appear consistently across multiple observation dates, when they show characteristics that match expectations for real physical flows rather than artifacts, you can trust that what you're seeing is genuine. Is actual structure present in the data rather than illusion created by processing? The symmetric pattern is real. The threefold spacing is measured. The stability across observation campaigns is documented. These aren't arguable points. These are established facts about what the observations show. The question is what those facts mean. What physical processes create symmetric jets that persist for months? What mechanisms produce threefold spacing with geometric precision? What explains the organization in ways that are consistent with known physics, but that don't require invoking so many special circumstances that the natural explanation becomes implausible? And this is where honest scientific discourse has to acknowledge that we don't have good answers yet, that the natural framework is struggling, that the observations are pushing against the boundaries of what conventional cometary physics can accommodate. The engineering hypothesis provides answers, provides straightforward explanations for why you'd see three jets at 120-degree spacing, for why they'd be stable rather than variable, for why they'd maintain symmetric configuration regardless of rotation state, if they're actively controlled systems rather than passive sublimation vents. But the engineering hypothesis also requires accepting that we're observing technology, that 3I Atlas is artificial, that we're not alone, and that whoever built this probe has capabilities we don't possess, and those are heavy conclusions, are exactly the kind of paradigm-shifting realizations that scientists are trained to approach with extreme caution. So we're in an uncomfortable position where the data is suggesting conclusions that the institutional culture isn't prepared to accept, where individual researchers analysing the observations are seeing patterns that indicate artificial origin, but where making that claim publicly remains professionally risky, where the gap between what the evidence shows and what can be said officially is creating tension that affects how the investigation proceeds and what questions get prioritised and what observations get funded. This tension isn't new, has existed throughout the study of 3I Atlas, has been present since the earliest observations revealed anomalies that didn't fit natural comet model comfortably. But the symmetric jets escalate the tension, make the gap between evidence and official narrative harder to ignore, create visual proof of organisation that anyone can see in processed images, rather than requiring specialised expertise to interpret mathematical calculations or spectroscopic data. The symmetry is democratising evidence, is making the case for artificial origin accessible to broader audience than just specialists who can follow the technical arguments. And that accessibility matters because it affects public discourse. Because when enough people see the symmetric jets and recognise the organisation and ask why natural processes would create that pattern, the pressure on institutions to respond honestly increases. The ability to maintain ambiguity decreases. The cost of continuing to treat artificial origin as fringe speculation, rather than as hypothesis, supported by mounting evidence becomes higher. Public awareness creates accountability, creates demand for transparency, creates environment where evasive official statements become less acceptable. The contrast with previous interstellar visitors is stark and illuminating. Oumuamua showed acceleration anomalies but no obvious structure that would indicate jets or thrusters. Was just enigmatic object moving in ways that required explaining, but that could potentially be explained through exotic natural mechanisms like solar sails or outgassing that we somehow failed to detect. The ambiguity remained. The debate continued. Natural versus artificial interpretations both remained viable because the observations didn't clearly favour either framework. Borisov was thoroughly conventional, showed exactly what we expect from natural comet, validated that interstellar visitors can be and sometimes are just ordinary comets that happen to originate from other stellar systems, demonstrated that not every anomalous trajectory or unusual visitor requires invoking artificial origin, provided comparison case that shows what natural interstellar comet actually looks like when you observe it carefully. But 3i Atlas is different from both, shows features that exceed what Oumuamua displayed, shows organisation that Borisov didn't exhibit, shows pattern of anomalies that distinguishes it from any natural object we've studied, while also showing features that engineering interpretation explains straightforwardly. The symmetric jets, a latest addition to that pattern, are visual confirmation of organisation that mathematical analysis had already suggested through rotation stability and anti-tail physics and trajectory evolution, are making visible what was previously only evident through quantitative analysis. The persistence across observation dates is critical for establishing that we're seeing real stable structure rather than transient feature or processing artifact. July 21st, observation showed the pattern. November the 30th confirmed it was still present months later. December 27th demonstrated continued stability. That's 3 observation epochs separated by weeks to months, all showing the same symmetric jet configuration. And between those epochs the object was rotating continuously, was completing hundreds of rotation cycles, was experiencing different solar illumination as its distance from the Sun changed and as its orientation relative to Earth evolved. Yet the jet pattern remained. Didn't vary with rotation in ways that natural sublimation-driven jets should vary. Didn't show evolution that would indicate changing surface conditions or active region migration. Just maintained stable, 3-fold symmetric configuration through all the rotation cycles and illumination changes and viewing geometry variations. That stability is exactly what you'd expect from engineered system, where jet positions are fixed by hardware locations rather than by where ice happens to be distributed. Is difficult to explain through natural processes that should be dynamic and variable rather than static and stable. The brightness variations that do occur in the jets provide additional information about what's creating them, because while the overall pattern is stable, the relative intensities of different jets change. One jet might be brighter at one observation epoch while a different jet dominates at another time. These variations could indicate rotation bringing different jets into better viewing geometry, where we see them more directly, could indicate changes in activity levels if the jets are controlled systems, operating at variable power levels, could indicate any number of mechanisms that affect apparent brightness without changing the underlying geometric pattern. For natural sublimation scenario, brightness variations would be expected as rotation brings active regions to different angles relative to sunlight and relative to our viewing direction. Regions facing more directly towards Sun would heat more intensely and sublimate more vigorously. Regions oriented such that we see the jets edge on would appear fainter than regions where we view jets from more favourable angle. These are well understood effects, are exactly the kind of variation that natural rotating comets should show, so seeing brightness variations doesn't contradict natural explanation, actually supports it in some ways because absence of any variation would be even harder to explain. But the pattern of variations might be informative, might show periodicities or correlations that indicate what's driving the intensity changes. If brightness variations correlate with rotation period in ways that are consistent with geometric effects, that supports natural interpretation where we're seeing passive structures at different angles. If variations don't correlate with rotation, if they seem independent of geometry, that suggests active control where jet power is being modulated according to operational logic, rather than according to passive response to illumination. Detailed analysis of the brightness variations across multiple observation dates would be needed to distinguish between these scenarios, would require tracking how each jet's intensity changes over time, correlating those changes with rotation phase and viewing geometry, looking for patterns that might reveal whether variations are passive consequences of geometry or active responses to mission requirements. That analysis is presumably being done by researchers with access to full dataset, might provide additional constraints on whether natural or engineered explanation better fits the detailed behaviour. The spatial structure of each individual jet also matters, because jets aren't just point sources, aren't just locations where material is being ejected, they're extended structures. Flows that have width and length an internal structure that might reveal information about ejection mechanism. For natural sublimation jets, you expect structure determined by gas dynamics. Expect expansion as gas flows away from source. Expect turbulence and instabilities that create complex internal patterns. Expect diffusion and entrainment that makes jet boundaries fuzzy rather than sharp. Engineered exhaust plumes might show different characteristics, might be more collimated if nozzles are designed to focus the flow, might show sharper boundaries if exhaust velocity is high enough that the plume doesn't mix significantly with surrounding environment, might exhibit internal structure determined by nozzle geometry rather than by chaotic fluid dynamics. So examining the detailed morphology of each jet, measuring their opening angles and collimation and internal structure, could provide clues about whether we're seeing natural or engineered flows. The current observations might not have sufficient resolution to characterize jet structure at that level of detail, might be limited by how small the nucleus appears even in Hubble images and by how much processing can enhance features before noise overwhelms signal. But future observations with better instruments or closer approaches might enable that analysis, might let us measure jet properties precisely enough to determine whether their behavior matches natural gas dynamics or whether they show signatures of engineered collimation and control. The overall configuration creates specific predictions that distinguish natural and engineered scenarios. Natural comet with active regions at random locations should show us symmetric jet patterns that vary as the object rotates and as different regions receive solar heating, should show jets appearing and disappearing, should show intensity changes correlating strongly with illumination geometry, should show chaotic rather than organized spatial distribution. None of these predictions match what we're observing from 3i Atlas. Engineered system with symmetric thruster arrangement should show stable jet pattern determined by hardware locations, should show brightness variations that might correlate with operational requirements rather than purely with geometry, should show collimation and structure consistent with designed nozzles rather than with random sublimation vents, should maintain configuration through rotation because jet positions are fixed to spacecraft rather than varying with surface features. All of these predictions match observations better than natural scenario does. This is how science should work when confronting anomalous data. You construct competing hypotheses. You derive predictions from each hypothesis about what you should observe if that hypothesis is correct. You compare predictions to actual observations. You evaluate which hypothesis better fits the data. And you update your confidence in each hypothesis based on how well its predictions match reality. That's Bayesian reasoning. That's evidence-based evaluation. That's the methodology that should guide conclusions rather than letting prior beliefs about what's possible or probable override what the evidence actually shows. And when you apply that methodology rigorously to 3i Atlas, when you compare natural and engineered hypotheses honestly without prejudice about which answer you prefer, the engineered hypothesis consistently provides better match to observations, better explains the symmetric jets, better explains the anti-tail physics, better explains the rotation stability, better explains the trajectory deviations, better explains the particle deployment, better explains the accumulated pattern of anomalies that individually might be explicable naturally, but that collectively create overwhelming case for design. The reluctance to accept this conclusion is understandable from sociological perspective. Accepting that 3i Atlas is artificial requires accepting that we're being visited, that intelligence exists beyond Earth, that we're not unique, that the galaxy contains civilizations that develop technology, allowing interstellar travel. These are profound realizations, are exactly the kind of paradigm shift that institutions resist, because accepting it requires reorganizing how we think about our cosmic context and our future and our significance. But resistance based on discomfort, with implications rather than on evaluation of evidence, isn't science, is ideology, is allowing preferences about what we want to be true to override what the data is telling us is actually true. And that's exactly the error that science is supposed to protect against, through rigorous methodology that forces us to follow evidence even when it leads to uncomfortable conclusions. The symmetric jets are evidence, are real observed structures, are patterns that require explanation. And the explanation that best fits all available data is that they're components of engineered system rather than products of natural chaos. The layered volatiles hypothesis represents the most sophisticated natural explanation that's been proposed for the symmetric jet structure. The idea is that the interior of 3I Atlas might have unusual composition, might have volatiles distributed in organized patterns determined by formation conditions, might have layers or regions with different ice compositions that create symmetric sublimation pattern when exposed to solar heating. This would be exotic, but potentially natural. Would invoke processes we haven't observed in solar system comets, but that might operate in different formation environments around different stars. The hypothesis requires explaining how layered structure forms, how you get organized distribution of volatiles rather than random mixture. Possible mechanisms include sequential condensation during formation, where different ices freeze out at different temperatures and create compositional gradients, or differentiation where heating and cooling cycles separate materials by volatility and create layered structure, or collision that exposes internal structure that was organized through processes operating in the parent body before the fragment that became 3I Atlas was ejected. Each mechanism is plausible in principle. Each operates according to known physics. Each could potentially create internal structure that's more organized than random accretion would produce. But getting threefold symmetric pattern from any of these mechanisms requires specific conditions. Requires explaining why the organization would manifest as three equally spaced active regions, rather than as some other pattern. Requires that the internal structure happens to align with surface geometry such that symmetric arrangement becomes visible. Requires stacking coincidences, and even if you accept that layered volatiles could create symmetric pattern initially, you need to explain why it persists, why the active regions don't migrate as sublimation erodes surface, why the pattern remains stable through months of activity that should be removing material and changing surface geometry, why the threefold symmetry is maintained rather than degrading into more chaotic pattern as random erosion processes modify the structure. Stability over long timescales is challenging for natural processes that should be inherently dynamic and evolution-driven. So the layered volatiles hypothesis, while more sophisticated than just claiming random active regions happen to be symmetric, still requires multiple special circumstances to work, still needs formation process that creates unusual structure, still needs erosion processes that maintain rather than destroy that structure, still needs geometric alignment between internal layers and surface features. Each requirement individually is possible. Together they create scenario that's plausible but not compelling. That could potentially explain observations, but that doesn't feel like natural outcome of ordinary processes. The engineering hypothesis doesn't require these special circumstances, doesn't need to invoke exotic formation or unusual composition or fortuitous alignments, just requires accepting that the object was designed. That symmetric jet arrangement was chosen because it serves functional purposes. That stability is maintained through active control rather than through lucky balance of competing processes. That what looks engineered actually is engineered because that's the simplest explanation for observed pattern rather than being conclusion we resist because implications are uncomfortable. The visual appearance in processed images is what makes this accessible to non-specialists in ways that mathematical proofs about ram pressure or spectroscopic arguments about gas velocities aren't. Because you can see the symmetry, can look at the filtered Hubble images and immediately recognize that the pattern is organized. Don't need expertise in fluid dynamics or cometry physics or astronomical image processing to see that three jets equally spaced around a nucleus looks designed rather than random. The visual evidence speaks directly to human pattern, recognition capabilities that are universal rather than requiring specialized training. And that democratization of evidence matters for public discourse. Because while specialists can debate mathematical models and argue about whether exotic natural processes might explain this or that anomaly, the visual evidence of symmetric structure is accessible to anyone, creates shared understanding that doesn't require trusting authority or accepting arguments you can't personally evaluate. You can look at the images yourself, can see the pattern, can make your own judgment about whether it looks natural or engineered. That transparency is powerful, creates foundation for informed public discussion that isn't limited to those with advanced degrees in relevant fields. The NASA silence on this topic is becoming increasingly conspicuous. The agency that's responsible for observing and characterizing objects in our solar system isn't commenting substantively on the accumulating anomalies that 3I Atlas displays, isn't addressing the symmetric jets, or the anti-tail physics, or the rotation peculiarities, or any of the features that make this object different from conventional comets. continues issuing generic statements about continued observation and ongoing analysis without providing specifics about what that analysis is revealing or what conclusions are emerging. This silence could be caution, could be institutional hesitancy about making claims before having complete confidence in conclusions, could be appropriate scientific restraint that avoids premature announcements that might need to be retracted or revised as more data becomes available. But it could also be evasion. Could be recognition that the evidence is pointing toward conclusions that the agency isn't prepared to communicate publicly. Could be discomfort with implications that would follow from officially acknowledging that observations suggest artificial origin. The pattern where individual researchers publish analyses showing specific anomalies, while the institutional response remains non-committal, creates awkward dynamic, creates perception that the evidence is being suppressed or downplayed, creates environment where conspiracy theories flourish because official narrative doesn't match what the data appears to show. Better approach would be transparent communication about what's being observed and what interpretations are being considered and what uncertainties remain. Even if conclusions aren't definitive, even if multiple hypotheses remain viable, honest discussion of the evidence serves public interest better than silence that breeds suspicion. The cumulative weight of evidence is what shifts the discussion from interesting anomaly to requires paradigm shift. Because any single observation, any individual feature that 3i Atlas displays, might be explicable through exotic but natural processes if you're willing to invoke special circumstances. But when you accumulate multiple independent anomalies, when each new observation adds another feature that requires explanation beyond conventional framework, when the pattern becomes one of systematic deviation from natural expectations rather than isolated curiosities, the burden shifts. Instead of the artificial hypothesis needing to prove itself against natural baseline, the natural hypothesis needs to justify why we should continue accepting it, despite mounting evidence that it's inadequate. The symmetric jets don't exist in isolation, aren't unconnected to the anti-tail or the rotation or the trajectory or the particles, or any of the other features we've been tracking. Instead, they're part of coherent pattern, part of systematic organization that extends across multiple observable characteristics, and that coherence is what makes the cumulative case so powerful. Because if the anomalies were independent, if they showed no relationship to each other, you could argue that we're just seeing a collection of unrelated, unusual features that happen to appear together coincidentally. But when the anomalies relate to each other, when they form pattern, where each supports and reinforces the others, coincidence becomes insufficient explanation. The rotation lock connects to the jets because it determines their geometry. If the rotation axis is aligned with the Sun as observations show, if that alignment is stable rather than precessing or wobbling, then jets located at the poles would maintain fixed orientation relative to solar direction, would create stable anti-tail if the sunward pole is active, would create stable counterjet if the anti-solar pole is active, would show exactly the kind of persistence across observation dates that we're seeing. So the rotation anomaly enables the jet stability, creates conditions where symmetric pattern can be maintained rather than varying chaotically as random rotation would produce. The anti-tail physics connects to the jets because it establishes that natural sublimation cannot account for observed gas distribution. The mathematical proof that CO2 cannot reach 100,000 kilometers if ejected at thermal velocities applies equally to the symmetric jets as it does to the anti-tail proper. If gas is present in the jet structures at distances where natural processes can't sustain it, then the jets can't be created through natural sublimation, regardless of how symmetric or asymmetric their spatial arrangement is. The propulsion requirement that applies to the anti-tail applies to all the jets, means they're all components of whatever technological system is operating, rather than some being natural and others being artificial. The trajectory deviations connect to the jets, because thrust requires exhaust. If the object is maneuvering, if it's executing course corrections that optimize the Jupiter encounter geometry, then it needs propulsion system, needs way to generate forces that change velocity, and the jets are the visible manifestation of that propulsion. Are the exhaust plumes from whatever drives are operating to create the observed trajectory changes, so the navigation anomalies and the jet structures aren't separate mysteries, are different aspects of same phenomenon where active propulsion creates both the forces that alter trajectory and the visible exhaust that we can observe and analyze. The particle deployment connects to the jets through the overall mission architecture. If 10 micrometer grains are being released deliberately to sample Earth's atmosphere or to serve other purposes, that deployment is coordinated with the jet operations, might use the same systems, might be timed relative to trajectory that the jets are helping execute, might be part of integrated mission where propulsion and sensing and whatever other functions the probe serves all operate in coordination toward objectives we're trying to infer from limited observations. So the symmetric jets aren't just interesting visual feature, a component of larger system where multiple anomalies interconnect and support each other, where accepting one piece of evidence for artificial origin strengthens the case for the others, where the pattern of organization extends across everything we can observe about this object. And that interconnected pattern is what makes the cumulative case overwhelming, even though any single piece might be individually explicable through sufficiently exotic natural processes. The engineering explanation unifies all these observations, provides single framework that accounts for rotation stability and anti-tail physics and symmetric jets and trajectory deviations and particle deployment without requiring separate special circumstances for each feature. Just requires accepting that we're observing spacecraft executing mission, that the rotation is controlled for operational purposes, that the jets are propulsion and attitude control, that the trajectory is navigated rather than ballistic, that the particles are deployed deliberately. Each observed feature becomes expected characteristic of operational probe rather than being anomaly requiring exotic natural explanation. And that unification, that ability to explain multiple independent observations through single coherent framework, is exactly what we look for in scientific theories. We prefer explanations that account for more phenomena with fewer assumptions, that provide unified understanding rather than requiring separate mechanisms for each observation, that make predictions about what else we should observe rather than just accommodating what we've already seen. The engineering hypothesis does all of this, makes 3i Atlas comprehensible as designed system rather than leaving it as collection of unexplained anomalies that natural framework struggles to accommodate. The resistance to this conclusion from parts of the scientific community represents understandable caution combined with less defensible reluctance to accept paradigm-shifting implications. The caution is appropriate. We should demand rigorous evidence before accepting that interstellar visitor is artificial, should exhaust natural explanations thoroughly, should be skeptical of extraordinary claims and should require extraordinary evidence before accepting them. That's how science should operate when confronting phenomena that challenge fundamental assumptions. But there's a point where continued resistance stops being appropriate caution and becomes denial, where insisting on natural explanations despite mounting contrary evidence reflects ideological commitment rather than rational evaluation, where the standards of proof being demanded are asymmetric, where natural hypotheses are accepted with far less evidential support than artificial hypotheses are required to meet. And that asymmetry is exactly what we should avoid if we're trying to let evidence guide conclusions, rather than allowing prejudices to determine what we're willing to accept. The symmetric jets are pushing the discussion toward that inflection point, are making the denial harder to maintain, are creating visual evidence that's accessible to broader audience and that makes the organization undeniable, are forcing the question of whether we're really following the evidence or whether we're protecting comfortable assumptions regardless of what the data shows. And how the scientific community responds to this pressure, whether it maintains openness to following evidence wherever it leads, or whether it retreats into defensive naturalism that refuses to consider artificial possibilities seriously, will determine whether this investigation proceeds productively or degenerates into unproductive debate where positions harden rather than converging toward truth. The observation strategy going forward should prioritize questions that distinguish between competing hypotheses, should focus on measurements that make different predictions under natural versus engineered scenarios, should seek evidence that might definitively resolve ambiguities rather than just collecting more data that's consistent with both interpretations, because at some point continued observation without hypothesis testing becomes inefficient, becomes collecting information without strategic purpose rather than executing investigation designed to answer specific questions. For the symmetric jets specifically, the critical measurements would characterize their detailed structure and behavior, high-resolution imaging that resolves the jet morphology, spectroscopy that determines composition and velocity of the flows, time series observations that track how jet brightness varies with rotation phase and with time, polarimetry that might reveal information about particle sizes and shapes in the jets. All of these observations could distinguish between natural sublimation and engineered exhaust. Natural sublimation jets should show gas velocities around thermal speeds, should show composition dominated by whatever volatiles are sublimating, should show brightness variations strongly correlated with solar illumination geometry, should show morphology consistent with turbulent gas dynamics, should show dust particle sizes distributed according to natural fragmentation. Each of these predictions can be tested through appropriate observations. Engineered exhaust should show higher velocities if propulsion is operating, should show composition that might include propellant choices optimized for efficiency rather than just naturally occurring ices, should show brightness variations that might not correlate with illumination if thrust is being modulated for operational reasons, should show morphology consistent with collimated nozzles, should show particle sizes that might be more uniform if particles are manufactured or if exhaust properties are controlled. Each of these predictions is also testable. A systematic observation campaign targeting these distinguishing features could resolve the natural versus artificial debate definitively, could collect evidence that clearly favours one interpretation over the other, rather than remaining ambiguous, could convert what's currently informed speculation into established conclusion through rigorous testing of competing predictions. That's exactly what should be happening. That's how scientific investigation should proceed when facing important questions that have testable answers. Whether that campaign is actually being executed, whether observations are being designed strategically to test hypotheses rather than just documenting whatever happens to be visible, is unclear from public information. The observation programs that are announced tend to emphasize general characterization rather than hypothesis testing, tend to describe monitoring the object and collecting data rather than targeting specific measurements that would distinguish between scenarios. That might reflect actual priorities or might just reflect how observations are described publicly, even when strategic hypothesis testing is occurring privately. But the opacity about what's actually being done and what results are being obtained creates frustration for those following the investigation from outside, creates perception that evidence is being gathered without clear plan for how it will be used to answer questions, creates worry that the investigation is being driven more by what's easy to observe than by what would be most informative, creates environment where skepticism about whether the right questions are being prioritized is reasonable. The technological capabilities required to resolve some questions definitively might not currently exist, or might not be accessible for 3i Atlas observations. Getting high enough resolution to see detailed jet structure might require closer approach than we can achieve with current assets. Measuring velocities precisely enough to distinguish thermal speeds from propulsion exhaust might require spectroscopic sensitivity we don't have. Tracking brightness variations with high enough cadence might require telescope time allocation that's not available for single-target monitoring. So there are real constraints on what observations are possible, real limitations that prevent some ideal measurements from being executed, even if we know they would be informative. And being honest about those constraints, about what we can and can't observe with existing capabilities, is important for setting realistic expectations about when questions might be answerable, versus when they'll remain uncertain until better instruments or closer access becomes available. But within the constraints, within what's actually possible with current telescopes and current observation windows and current resource allocations, there should be strategic prioritization, should be decisions about which observations provide most value for distinguishing hypotheses, should be coordination across facilities to maximize coverage and to avoid duplicating efforts unnecessarily, should be transparency about what's being observed and what the results show so that the broader community can contribute to interpretation and can identify observations that aren't being done but should be. The symmetric jets create specific opportunity for ground-based participation. Because while detailed spectroscopy and high-resolution imaging might require space telescopes or large professional observatories, monitoring for variability and documenting persistence of the pattern is achievable with more modest instruments. Amateur astronomers with appropriate equipment can contribute observations, can track how jet brightness changes over time, can verify that the symmetric pattern continues to appear in new data, can provide temporal coverage that complements the snapshot observations from professional facilities. And that distributed observation network has value beyond just collecting more data, has value in ensuring observations are publicly available, in preventing any single authority from controlling the narrative about what's being seen, in creating redundancy that makes suppression or selective reporting more difficult, in democratizing the investigation such that conclusions are grounded in evidence that multiple independent observers can verify rather than depending on pronouncements from centralized institutions. The call for transparency about what NASA and other space agencies are observing extends beyond just 3i Atlas. Extends to broader question of how we handle discoveries that might have profound implications, because if this object is artificial, if we're documenting first confirmed encounter with extraterrestrial technology, then the evidence belongs to humanity rather than to specific institutions. The knowledge affects everyone. The implications extend to all future generations, and democratic access to information, public participation in discourse about how to interpret evidence and how to respond, is essential for legitimate decision-making. But current information environment is far from that ideal. Evidence emerges through technical publications that most people can't access or interpret. Analysis is conducted by specialists using methods and data that aren't public. Conclusions are reached through processes that aren't transparent. And communication to broader audiences filtered through institutional messaging that emphasizes caution and ambiguity, even when evidence might support more definitive statements. That's not healthy dynamic when investigating questions this important. Better approach would be real-time data sharing, public archives where raw observations are available immediately, open-source analysis tools that allow independent verification of results, clear communication about what hypotheses are being considered and what evidence supports or contradicts each. Acknowledgement of uncertainties without using uncertainty as excuse to avoid stating what the evidence currently suggests, even if conclusions might change with additional data. Trust in public capacity to handle complex information and to participate meaningfully in discourse about implications. Some of this is starting to happen with 3i Atlas. The Hubble images are archived, the processing techniques are documented, individual researchers are publishing analyses and discussing findings openly, even when official institutional statements remain non-committal. That's progress. That's movement toward the transparency that serves public interest, but it's incomplete. Still too much happening privately, still too much analysis that isn't shared publicly, still too much filtering of information through institutional gatekeepers who decide what should or shouldn't be communicated broadly. And the symmetric jets, because they're visual evidence that's accessible without requiring specialized expertise to interpret, are helping drive movement toward greater openness. Because when you can see the pattern in processed images that researchers share, when you can recognize the organization without needing to understand cometry physics or spectroscopic analysis, the barrier to entry for participating in discussion drops dramatically. More people can engage, more perspectives can contribute, more pressure builds for institutions to communicate honestly rather than maintaining ambiguity that serves their interests rather than public understanding. The comparison to how Oumuamua was handled is instructive. That object generated enormous public interest, captured imagination because it was first confirmed interstellar visitor and because its unusual properties sparked debate about artificial origin. But the investigation remained largely opaque to public. Observations were reported in technical papers. Analysis was conducted by specialists. The debate about natural versus artificial interpretations played out in professional literature and conference presentations rather than in accessible public discourse. And the result was that most people following the story got simplified narrative that didn't capture the actual state of evidence or the real uncertainties, got told that natural explanations were adequate even though the specialists debating the question were far from consensus, got impression that the artificial hypothesis had been thoroughly tested and rejected, when in fact it remained viable and was being actively defended by credible researchers. The gap between what the evidence actually showed and what public communication suggested created an environment ripe for misinformation and conspiracy theories. 3i Atlas investigation has opportunity to do better, to communicate more transparently about what's being observed and what it might mean, to acknowledge when natural explanations are struggling rather than maintaining false confidence that they're adequate, to treat public as capable of engaging with complex, uncertain evidence rather than needing to be protected from unsettling possibilities, to create shared understanding that serves as foundation for collective decision-making about how to respond if artificial origin is confirmed. The symmetric jets are a test case for whether that opportunity will be seized. whether the visual evidence that makes organization undeniable will force more honest communication, whether institutions will acknowledge what the pattern suggests even if definitive proof remains elusive, whether the investigation proceeds openly with public participation, or whether it retreats into controlled messaging that protects institutional interests at expense of transparency. The stakes are high, because this isn't just academic question about classifying unusual object. It's potentially first contact with extraterrestrial intelligence, even if that contact is mediated through artifact rather than direct interaction. Is discovery that would fundamentally alter humanity's cosmic perspective, and that would raise profound questions about our future and our responsibilities and our place in universe that might be more populated than we believed. Those aren't questions that institutions should address privately and then inform public of conclusions. Those are questions that demand public engagement from beginning. That require a transparent process where evidence is shared and interpretations are debated and decisions about how to respond are made collectively. And the symmetric jets, by making the evidence visual and accessible, are creating pressure for that engagement, are making it harder to maintain narrative that everything is conventional, even though observations keep revealing organization, are forcing conversation about what we're actually seeing to include broader participation rather than remaining confined to specialist community, are democratizing first contact if that's what this turns out to be. The future observations will either confirm or refute the patterns we're currently seeing. Will either show that the symmetric jets persist as the object continues its trajectory through the solar system, or will show that they were transient features that appeared under specific conditions and then disappeared as those conditions changed. Will either reveal additional organizational signatures that strengthen the case for artificial origin, or will show variations and irregularities that make natural explanations more plausible. The object isn't leaving the inner solar system immediately, will remain observable for months to come, will provide opportunities for follow-up measurements that test the hypotheses that current observations have generated. And those follow-up observations are critical because current data, as compelling as it is, remains incomplete. We've seen symmetric jets at 3 observation epochs, have documented that the pattern persists across several months, but we don't have continuous monitoring, don't have high-cadence time series that would show how the jets vary on shorter timescales, don't have spectroscopic characterization of the jet composition and velocities, don't have the full suite of measurements that would definitively distinguish between natural and engineered explanations. So while the evidence is suggestive, while it points toward conclusions that challenge comfortable assumptions, it's not yet conclusive in the sense that no alternative interpretation remains viable. That's honest assessment of where we are. The symmetric jets are real, are documented across multiple observations using rigorous processing methodology. Show organization that's difficult to explain through natural processes without invoking special circumstances. Fit pattern of accumulated anomalies that collectively make strong case for artificial origin. But definitive proof requires more, requires measurements we haven't made yet, requires observations that might or might not be possible before the object fades beyond reach of our instruments. So the investigation continues, the data accumulates, the analysis proceeds. And with each new observation, with each additional measurement, the picture either clarifies toward one interpretation or the ambiguity persists as different observations support different hypotheses. That's the nature of frontier science, where you're studying phenomena that don't fit established frameworks cleanly, where you're pushing into territory where the answers aren't known and where the evidence doesn't immediately resolve all questions, but instead raises new ones that require further investigation. The symmetric jets contribute to that ongoing investigation by providing visual evidence of organization, by creating feature that's accessible to broader audience than just specialists, by forcing the question of whether we're seeing design or whether nature creates patterns this organized through processes we don't yet understand, and by doing so in ways that are documentable and verifiable, and that invite scrutiny rather than requiring trust in authority or acceptance of claims that can't be independently evaluated. That accessibility is powerful, is exactly what moves scientific questions from specialist debates into broader public discourse, is what creates accountability for how investigations are conducted and how evidence is interpreted and how conclusions are communicated, is what prevents any single narrative from dominating without challenge, is what ensures that the investigation serves truth-seeking rather than institutional interests or ideological commitments that might bias interpretation. And 3i Atlas, through the accumulation of anomalies that now include symmetric jets, is forcing that broader discourse whether institutions are ready for it or not, is creating a situation where visual evidence that anyone can see in processed images combines with mathematical proofs about physical impossibilities and with trajectory measurements showing non-gravitational acceleration to create case that's difficult to dismiss. That demands serious engagement with artificial hypothesis rather than reflexive insistence on natural framework. That shifts burden of proof such that natural explanations need to justify why they should still be accepted despite mounting contrary evidence. The comparison to historical paradigm shifts is illuminating. When Copernicus proposed that Earth orbits the Sun rather than being centre of the cosmos, the evidence was there but required accepting conclusions that challenged fundamental assumptions about humanity's place in the universe. Resistance was fierce. Alternative explanations were proposed that preserved Earth-centric view through increasingly convoluted mechanisms. Eventually, the evidence became overwhelming and the paradigm shifted. But not without considerable struggle, and not without some defenders of the old framework refusing to accept the new one, even when evidence clearly favoured it. We might be in a similar situation with 3i Atlas, where evidence pointing toward artificial origin is accumulating, but where accepting that conclusion requires paradigm shift about whether we're alone and whether the galaxy contains other technological civilizations, where resistance to the conclusion reflects discomfort with implications rather than an inadequacy of evidence, where alternative natural explanations keep getting proposed, even as each successive one requires more special circumstances and more exotic mechanisms to account for observations, where eventually the weight of evidence will force acceptance but not without period of debate and denial and gradual shift in consensus. How long that transition takes depends on how rapidly evidence accumulates and how compellingly it favours one interpretation over alternatives. The symmetric jets accelerate the process by providing visual proof of organisation, by making the case accessible beyond specialist community, by creating pressure for honest communication about what observations show, but they're not sufficient alone to force paradigm shift, are part of cumulative case that includes multiple independent lines of evidence, all pointing towards same conclusion. And the strength of that cumulative case is that it doesn't depend on any single observation being definitive. Doesn't require that symmetric jets alone prove artificial origin. Instead, builds from combination of features where each individually is suggestive and collectively they become overwhelming, where the probability that all the anomalies are coincidental becomes vanishingly small, where the simplest explanation that accounts for all observations simultaneously is artificial origin, even though that explanation requires accepting conclusions that challenge our cosmic isolation. The role of individual researchers versus institutional positions is creating interesting dynamic. Because the researchers analysing the data, the specialists with expertise to evaluate evidence rigorously, are reaching conclusions that institutions aren't yet ready to communicate officially, are publishing papers showing specific anomalies, are discussing artificial possibilities in professional contexts, are treating the hypothesis seriously rather than dismissing it as fringe speculation. But those individual conclusions aren't translating into official statements from NASA or ESA or other space agencies that acknowledge what the accumulated evidence suggests. This gap between researcher consensus and institutional messaging creates tension, creates perception that evidence is being suppressed or downplayed, creates an environment where public doesn't get accurate picture of what specialists actually think, because official communications emphasize uncertainty and ambiguity even when individual researchers are reaching more definitive conclusions, and that gap needs to close. Either through institutions becoming more transparent about what evidence shows, or through researchers communicating directly with public without filtering through institutional gatekeepers. The symmetric jets are helping close that gap because they're visual, because researchers can share processed images showing the pattern, can point to features that anyone can see, rather than relying on technical arguments that require specialized background to evaluate, can communicate directly through social media and public talks and articles in accessible venues without needing institutional approval or filtering. And that direct communication is creating parallel narrative that's more aligned with what evidence actually shows than official institutional statements are. But direct communication from individual researchers also creates challenges, creates risk of fragmentation, where different specialists reach different conclusions based on same data, creates possibility of miscommunication or oversimplification when complex technical evidence is translated for public audiences, creates potential for sensationalism if researchers seeking attention make stronger claims than evidence supports. So while transparency and direct communication are valuable, they need to be accompanied by rigor and honesty about uncertainties and commitment to following evidence rather than promoting preferred narratives. The balance is difficult to achieve. How do you communicate openly about evidence that's suggestive but not definitive? How do you acknowledge that artificial origin is a serious possibility without claiming it's proven? How do you maintain scientific rigor while making evidence accessible to non-specialists? How do you avoid both the false certainty that exaggerates what we know and the false equivalence that treats all hypotheses as equally viable when evidence clearly favours some over others? These are questions the 3i Atlas investigation is forcing the scientific community to confront. Questions about how to communicate about frontier science when the questions matter profoundly, and when the evidence is accumulating but conclusions remain provisional. Questions about who has authority to interpret observations and how that authority should be exercised responsibly. Questions about what public has right to know and when they have right to know it and who makes those decisions, and the symmetric jets are making these questions urgent. Are creating a situation where visual evidence is public, where anyone with access to processed Hubble images can see the pattern, where the organisation is undeniable even if its origin remains debatable, where institutions can't control narrative by controlling access to evidence because the evidence is already distributed widely, where the investigation proceeds in public view rather than behind closed doors with carefully managed communication about what's being discovered. That's good for democracy, good for ensuring that discoveries that affect everyone are understood by everyone, rather than being mediated through authorities who might have interests in shaping how information is presented, good for creating informed discourse about implications and responses, good for preventing decisions about how to handle contact scenarios from being made exclusively by specialists without input from broader society that will live with consequences of those decisions. But it also creates challenges, creates noise alongside signal, creates environment where speculation and evidence get mixed together in ways that make distinguishing them difficult for those without expertise, creates opportunity for misinformation to spread as rapidly as accurate information, creates pressure for premature conclusions before evidence is sufficient to support them definitively. All the challenges that come with open public discourse about complex technical questions where expertise matters but shouldn't be the only voice that shapes understanding. The path forward requires balancing these tensions. Maintaining scientific rigor while communicating openly, acknowledging uncertainties while stating clearly what evidence currently suggests, following where observations lead without getting ahead of what can actually be concluded, engaging public as partners in the investigation rather than as audience that needs to be protected from unsettling possibilities, trusting in collective capacity to handle complex ambiguous information rather than assuming that simplified narratives are necessary to prevent confusion or panic. 3i Atlas is testing whether the scientific community and society more broadly can achieve that balance, whether we can investigate questions about potential extraterrestrial technology openly and rigorously simultaneously, whether we can communicate honestly about what we're observing without exaggerating or downplaying, whether we can follow evidence toward conclusions that might be paradigm shifting while maintaining appropriate skepticism and demanding sufficient proof before accepting extraordinary claims. The symmetric jets are part of that test, our evidence that demands interpretation, a pattern that requires explanation, our observation that contributes to cumulative case for artificial origin, while also being individually consistent with exotic natural processes if you're willing to invoke enough special circumstances. How we handle this evidence, how we communicate about it, how we use it to inform our investigation and our understanding, will demonstrate whether we're capable of approaching these profound questions with the rigor and openness and honesty they deserve. And the stakes couldn't be higher, because if 3i Atlas is artificial, if we're documenting first confirmed encounter with extraterrestrial technology, then how we handle this discovery sets precedents for all future encounters, establishes frameworks for how we investigate, determines what information is shared and what remains controlled, shapes public understanding of our cosmic context, influences how we think about our future as potentially one civilization among many, rather than as isolated experiment in intelligence. Those precedents matter. Those frameworks will constrain options when future visitors arrive or when we discover artifacts elsewhere. Those patterns of communication will determine whether the public trusts institutions to be honest about what's being discovered, or whether skepticism and conspiracy theories dominate because official narratives don't match what evidence suggests. This is our chance to establish healthy patterns, to demonstrate that transparency serves truth better than control, to show that public can engage maturely with unsettling information when it's presented honestly. The symmetric jets, because they're visual evidence of organization, because they're accessible to broad audience, because they make the case for artificial origin tangible rather than purely abstract, are opportunity to practice that transparency, to share what we're seeing, to explain why it matters, to discuss what it might mean, to acknowledge uncertainties while being clear about what the pattern suggests, to engage public as participants in the investigation rather than as audience waiting to be told what conclusions specialists have reached. And the response so far, the public engagement with the evidence about 3I Atlas, suggests that trust in public capacity is warranted. People are following the observations, are asking informed questions, are distinguishing between speculation and evidence, are demanding honesty rather than simplified narratives, are demonstrating that they can handle complexity and ambiguity and unsettling possibilities without panic or rejection, are showing that the concerns about public not being ready for certain kinds of information are probably overblown and condescending. So the challenge to institutions is, match that capacity. Communicate at the level that public discourse is already operating at, rather than assuming simplified messaging is necessary. Share evidence openly and explain what it means and acknowledge what's uncertain and trust that people can process complex information responsibly. Use the symmetric jets as opportunity to demonstrate that transparency works. That honest communication about anomalous observations serves public interest better than carefully managed messaging that emphasizes caution and ambiguity to protect institutional credibility. Because institutional credibility ultimately depends on trust, and trust depends on honesty. And honesty about 3I Atlas requires acknowledging that observations are revealing patterns that challenge natural explanations. That symmetric jets look organized because they are organized. That the organization might be natural but requires exotic mechanisms or might be artificial, and requires accepting that we're being visited. That evidence is accumulating faster than explanations are keeping up. That we don't have all answers yet, but we're asking right questions and following where data leads. That's the message that serves public interest, that builds trust, that creates foundation for continued support of the investigation and for informed discourse about implications and responses. That treats public as adults capable of engaging with reality, rather than as children who need to be protected from unsettling truths. And it's the message that the symmetric jets make possible, because they provide visual evidence that anyone can see and evaluate, rather than requiring trust in authority or acceptance of technical arguments that can't be independently verified. The future of this investigation, the trajectory of how we understand 3I Atlas, and what conclusions we ultimately reach, depends on whether we embrace that transparency or whether we retreat into controlled messaging that serves institutional interests rather than truth-seeking. The evidence will accumulate regardless. The object will continue exhibiting whatever behaviors it exhibits, regardless of how we communicate about them. But whether those observations lead to shared understanding that serves as foundation for collective decision-making, or whether they create division between those with access to evidence and those dependent on filtered institutional communications depends on choices about transparency that are being made now. And the symmetric jets are forcing those choices, are making evidence public in ways that can't be controlled, are creating a situation where institutional messaging either aligns with what the visual evidence shows or loses credibility by maintaining narrative that doesn't match what people can see for themselves. That's exactly the kind of pressure that pushes toward transparency. That makes honest communication more valuable than managed messaging. That serves public interest by ensuring that understanding is grounded in evidence, rather than in what authorities decide is appropriate to share. So in the final analysis, the symmetric jets matter, not just because they're evidence of organization on 3I Atlas, not just because they contribute to cumulative case for artificial origin, but because they're accessible evidence, are visual proof that democratizes the investigation. That enables broad participation in interpreting observations and discussing implications, that forces transparency by making key evidence public, that serves as test case for whether we can handle profound discoveries openly and honestly rather than through controlled messaging, that protects institutions at expense of public understanding, and if we handle this well, if we communicate transparently about what the symmetric jets show and what they might mean and what uncertainties remain, we establish precedent that serves us well for future discoveries. That builds trust between institutions and public. That creates framework for continued investigation that serves truth-seeking rather than institutional interests. That demonstrates our capacity to confront paradigm-shifting evidence maturely and rigorously and openly. That's the opportunity. That's what the symmetric jets offer beyond just being another anomaly. To add to the growing list, their chance to do better, to communicate more honestly, to engage more openly, to investigate more transparently, to demonstrate that we're capable of handling profound questions about our cosmic context and our isolation and our future with the seriousness and the honesty and the rigor that they deserve. 3i Atlas continues its journey through our solar system, continues exhibiting behaviors that challenge our understanding, continues accumulating evidence through observations that reveal organization rather than chaos. And the symmetric jets are latest chapter in that story, latest observation that demands explanation, latest pattern that suggests design rather than random natural processes, latest piece of evidence that pushes the cumulative case toward conclusions that are uncomfortable, but that might be true regardless of our comfort. And we have opportunity to document this properly, to investigate rigorously, to communicate honestly, to engage publicly, to follow evidence wherever it leads, to accept conclusions when evidence supports them, even if implications are paradigm-shifting, to demonstrate that science works not by protecting comfortable assumptions, but by following observations and analysis toward truth regardless of whether that truth matches our expectations or our preferences. The symmetric jets are calling us to that higher standard, are providing evidence that tests our commitment to following data rather than defending frameworks, are creating opportunity to show that we're capable of honest investigation and transparent communication even when questions are profound and answers are unsettling, are demonstrating that the universe continues to surprise us and that our responsibility is to observe carefully and reason rigorously and communicate honestly about what we're discovering. So let the symmetric jets be the symbol of that commitment. Let them represent the moment when we chose transparency over control, when we chose evidence over ideology, when we chose honest engagement with profound questions over defensive protection of comfortable assumptions, when we demonstrated that humanity is capable of confronting the possibility that we're not alone with maturity and rigor and openness that serves our collective future. The visitor came, the observations accumulated, the patterns emerged, the symmetric jets revealed organization, and now we choose how to respond, how to investigate, how to communicate. How to engage with evidence that challenges everything we thought we knew about our cosmic isolation. That's the moment we're in. That's the test we're facing. And the symmetric jets, visible and undeniable and organized, are the evidence that makes this choice unavoidable and urgent and profound. Follow the evidence, communicate honestly, engage openly. And let's discover together what the universe is actually showing us rather than what we wish it would show. Because truth, whatever it turns out to be, serves us better than comfortable illusions. And the symmetric jets of 3i Atlas are pointing us toward truth, even if that truth is more extraordinary than we were prepared to accept. Part 5, bonus, 10,000 words. The mathematical analysis of the symmetric jet pattern provides quantitative foundation for what visual inspection suggests qualitatively. Because while the human eye can recognize organization and can see that the jet arrangement looks deliberate rather than random, science requires more than visual impression, requires measurements that quantify the symmetry, requires statistical analysis that determines whether the pattern could arise from chance or whether it represents genuine organization that demands explanation. And when you perform that analysis rigorously, when you apply proper statistical methodology to the jet positions and spacings and intensities, the results confirm what intuition suggests. This is not random configuration. The angular spacing is the most straightforward measurement. 3 jets positioned around the nucleus at what angles? If the arrangement were random, if active regions just happened to develop wherever ice patches existed, without any relationship to overall geometry, you'd expect random angular distribution. Some jets might be clustered close together, others might be widely separated. The spacing would vary, would show no particular pattern, would be different every time you looked at a different comet because there's no mechanism that would consistently produce specific geometric relationships. But measure the angles between the jets on 3i Atlas, and you get approximately 120 degrees. Not exactly 120. The measurements have uncertainty. The processed images have limited resolution. The jets themselves have finite width that makes defining their exact direction ambiguous. But within measurement uncertainty, the spacing is consistent with perfect threefold symmetry, where 360 degrees is divided equally among 3 features. The deviation from exact 120-degree spacing is small enough that it could be measurement error rather than indicating the symmetry isn't perfect. Calculate the probability that random placement would produce this result, would produce 3 jets with angular spacing that close to perfect symmetry. The calculation depends on what tolerance you accept for close to perfect. If you require the spacing to be within 5 degrees of 120, the probability is small. If you accept 10-degree tolerance, the probability increases but remains low. For any reasonable criterion, the odds of random placement producing the observed configuration are less than a few percent, are low enough that coincidence becomes uncomfortable explanation. And that's just for the angular spacing. Doesn't account for the fact that the jets also show similar intensities, similar lengths, similar morphologies. If the arrangement were random, if jets were independent features arising from unrelated processes at different surface locations, you wouldn't expect them to look similar. Would expect variation in brightness reflecting different sublimation rates. Would expect variation in collimation reflecting different local geometries. Would expect each jet to be unique rather than appearing as similar features just pointed in different directions. But the symmetric jets show remarkable similarity, not perfect uniformity. Each has individual characteristics, but overall they appear as variants of common template rather than as completely independent structures, and that similarity, combined with the geometric spacing, compounds the improbability of random origin. Because now you're not just requiring that 3 active regions happen to be positioned at 120-degree intervals. You're requiring that they also happen to produce jets with similar properties, despite arising from potentially different local conditions. Multiply the probabilities together. Angular spacing at maybe 2%. Similar intensities at maybe 10% if we're generous about how much variation counts as similar. Similar morphologies at another 10%. The cumulative probability drops to 0.02%. 1 chance in 5,000, still possible. Still within realm of what might occur by coincidence occasionally, but uncomfortable enough that you start seriously considering whether random processes are actually adequate explanation, or whether you're seeing organization that requires different framework. The temporal stability multiplies those probabilities further, because the pattern doesn't just appear once, appears in July observations, persists through November, continues in December, 3 observation epochs. If the symmetric arrangement were temporary configuration that arose coincidentally from rotation, bringing independent active regions into momentary alignment, you wouldn't expect it to persist. Would expect it to appear at one observation and be gone at the next, as rotation changed the relative positions of the jets, or as different regions became active or dormant. But it persists, maintains configuration across months during which the object completed hundreds of rotation cycles, during which solar illumination varied as the object's distance from the sun changed, during which viewing geometry changed as Earth's position relative to the object evolved. Through all those changes, through all that rotation and all that variation in conditions, the symmetric pattern remains stable. And that stability is exactly what you'd expect if the jets are fixed to hardware, rather than being transient features arising from surface processes that respond dynamically to changing conditions. Calculate the probability that coincidental symmetric arrangement would persist across 3 independent observations separated by months. If the probability at any single observation is 1 in 5,000, and if the observations are independent such that seeing the pattern at one time doesn't make it more likely at another time, then seeing it at all 3 observations is 1 in 5,000 cubed. 1 in 125 billion. A probability so small that coincidence stops being viable explanation, and you're forced to conclude that the pattern is real and stable, rather than being three independent coincidences. Now, the observations aren't completely independent. If the object has stable surface features, if the same active regions remain active across the observation period, then seeing symmetric pattern at one time does make it more likely at subsequent times because you're observing the same underlying structure rather than completely new random configurations. So the calculation isn't quite as simple as just cubing the single observation probability. The true probability is higher than 1 in 125 billion. But even accounting for correlation between observations, even being generous about how much the temporal dependence increases the probability, you still end up with numbers that are vanishingly small for coincidental symmetric arrangement, persisting across multiple observation epochs. The pattern is either real and stable, or we're witnessing statistical fluke so unlikely that we should be skeptical, it's actually chance, rather than indication, that our assumptions about randomness are wrong. And this is exactly the kind of quantitative analysis that distinguishes between genuine scientific reasoning and intuitive pattern recognition that might be biased by our tendency to see organization even in random data. Because calculating probabilities rigorously, accounting for measurement uncertainties, and for dependence between observations and for the full range of possible configurations that might occur, provides objective measure of whether observed pattern is surprising under random hypothesis, or whether it's expected outcome of processes we're assuming are operating. The symmetric jets are surprising, are statistically significant, are unlikely enough under random placement hypothesis that we should seriously consider alternative explanations where the organization is real and where mechanisms creating it are deterministic rather than stochastic, and that conclusion emerges from mathematics rather than from visual impression, emerges from rigorous analysis rather than from intuitive recognition of pattern, emerges from exactly the kind of quantitative methodology that science demands when evaluating whether observations require new explanations or whether conventional frameworks remain adequate. The comparison to solar system comets provides empirical baseline for assessing whether threefold symmetric jet patterns ever arise naturally, because we've observed hundreds of comets, have detailed studies of jets and active regions on dozens of well-characterized examples, have extensive datasets showing how jets behave, how they're distributed spatially, how they vary temporally, and what geometric relationships, if any, they exhibit. And that empirical baseline is what we compare 3i Atlas against, to determine whether its jet pattern is unusual or whether it falls within the range of natural variation. Survey the literature, examine published studies of cometary jets, look for examples of symmetric patterns, look for threefold geometric relationships, look for cases where jets positioned around the nucleus show spacing that approximates equal angular intervals, and what you find is nothing. No examples of threefold symmetry. No cases where jets at 120-degree spacing persist across multiple observations. No precedent for the pattern that 3i Atlas displays. You find plenty of multiple jets. Many comets show multiple active regions producing jets in different directions. You find temporal variation where jets come and go as rotation brings regions into and out of sunlight. You find all the chaos and irregularity that natural sublimation produces when random ice distribution interacts with rotation and solar heating. But you don't find organization, don't find geometric relationships that persist, don't find patterns that look designed rather than random. The absence of precedent is significant, doesn't prove that natural processes can't create symmetric jets, doesn't establish that 3i Atlas must be artificial because no natural comet has shown similar pattern. But it does mean that if the pattern is natural, it requires processes or conditions that haven't been observed in the hundreds of comets we've studied previously, requires something exotic, something that operates differently from the sublimation-driven jet formation that creates the chaotic asymmetric patterns we see everywhere else. And when you're invoking exotic processes to explain single object while all other objects behave conventionally, you should be cautious about claiming you've found natural explanation. Because if the processes were truly natural, if they operated according to physics that's common rather than requiring unusual circumstances, you'd expect to see the pattern occasionally in the large sample of objects that have been observed. The fact that you don't, the fact that 3i Atlas appears unique in this regard, suggests that either the required conditions are extremely rare or the explanation isn't natural at all. This is where Bayesian reasoning becomes powerful. You start with prior probabilities about how likely natural versus artificial origins are for interstellar visitors. Those priors reflect your beliefs before examining any specific evidence about 3I Atlas. Maybe you think 99% of interstellar objects are natural, and 1% are artificial, based on assumptions about how common technological civilizations are, and whether they send probes to other stellar systems. Then you update based on evidence. Each observation that favors one hypothesis over the other shifts the probability. Symmetric jets that never appear in natural comets, but that would be expected design choice for spacecraft, that's evidence favoring artificial, shift the probabilities. Anti-tail physics that violates natural sublimation constraints but that matches engineered propulsion predictions, more evidence favoring artificial, shift further, and as you accumulate evidence, as each new observation favors artificial over natural, the probabilities evolve. Eventually, even if you started with very strong prior favoring natural origin, enough evidence drives the posterior probability toward artificial. Drives it to the point where continuing to assert natural explanation requires dismissing evidence or applying asymmetric standards where natural hypotheses are accepted despite lack of support, while artificial hypotheses are rejected despite mounting confirmation. The symmetric jets are a major update in this Bayesian calculation. Our observation that natural comet hypothesis predicts should be extremely rare while artificial spacecraft hypothesis predicts might be common design choice. So seeing symmetric jets shifts probability substantially toward artificial. Combined with all the previous updates from anti-tail and rotation and trajectory and particles, the cumulative shift might be large enough that posterior probability for artificial origin exceeds 50%. Might cross the threshold where it becomes more likely than natural, even for someone who started with very skeptical priors. And crossing that threshold matters psychologically, even if it doesn't represent sharp boundaries scientifically. Because when probability that something is artificial exceeds probability that it's natural, you're no longer defending unlikely position by considering artificial origin seriously. You're following the evidence to its most probable conclusion. You're accepting what Bayesian analysis indicates rather than maintaining agnosticism or favoring natural explanation based on prejudice rather than on probability calculations. The engineering optimization perspective provides complementary approach to evaluating whether symmetric jets indicate design. Because engineers optimize, design systems to achieve objectives efficiently, make choices that serve functional purposes rather than just accepting whatever random configurations might arise. And threefold symmetric thruster arrangement is exactly the kind of optimization that spacecraft designers would implement if they needed attitude control and propulsion with minimal hardware. Consider the problem. You want to be able to orient your spacecraft in any direction. Want to be able to apply thrust along any axis to execute maneuvers. How many thrusters do you need and where do you position them? The answer depends on how much redundancy you want and how much mass you're willing to allocate to propulsion systems. But the minimum configuration that provides full three-axis control is 3 thrusters arranged symmetrically. Each thruster points in different direction. By firing appropriate combination of thrusters at appropriate power levels, you can create net thrust in any desired direction. Want to thrust forward? Fire all 3 equally. Want to rotate? Fire some but not others to create torque. Want to execute complex maneuver combining translation and rotation? Fire thrusters in sequence or in specific combinations that achieve the desired motion. 3 symmetric thrusters give you complete control with minimal hardware. And the optimal geometric arrangement is exactly what we observe. 3-fold symmetry with 120-degree spacing. This provides maximum efficiency for creating thrust in any direction. Provides balanced configuration that doesn't create preferential axes where control is stronger or weaker. Provides redundancy such that even if one thruster fails, you still have some maneuvering capability with the remaining 2. It's exactly what you'd design if you were building spacecraft that needs versatile propulsion. So from engineering optimization perspective, the symmetric jet pattern on 3I Atlas looks like deliberate design choice, rather than like random feature. Looks like solution to spacecraft control problem rather than like coincidental arrangement of natural sublimation vents. And that appearance is another piece of evidence that shifts Bayesian probabilities toward artificial origin, because engineered explanation predicts this configuration while natural explanation struggles to account for it. The layered structure hypothesis represents the most sophisticated natural alternative that's been proposed to explain the symmetric jets. This idea invokes unusual internal composition, where volatiles are distributed in organized patterns rather than being randomly mixed, where the nucleus has structure, potentially created through formation processes or through differentiation that occurred in the parent body before the fragment that became 3I Atlas was ejected, and where that internal structure happens to create symmetric arrangement of active regions when exposed to solar heating. The hypothesis is ingenious, is attempt to construct natural mechanism that could produce observed pattern without requiring coincidence, and it deserves serious evaluation rather than dismissal. But evaluation reveals challenges. Reveals that while the hypothesis is possible in principle, implementing it requires specific conditions that aren't obviously achieved through normal processes and that themselves might require explanation. How do you get layered structure with threefold symmetry? Formation through sequential condensation might create layers as different volatiles freeze out at different temperatures, but those layers would be radial, would create shells of different composition at different depths, wouldn't naturally create threefold angular structure where composition varies with position around the nucleus rather than just with depth. Getting angular structure requires different mechanism. Differentiation might create compositional gradients if the parent body was large enough that gravity could separate materials by density, or if thermal processing drove chemical fractionation. But again, differentiation typically creates radial structure, core mantle differentiation that we see in planets, layering by depth rather than by angular position. Getting threefold angular structure requires that differentiation operates in specific ways that aren't typical of how we understand these processes work. Collision could expose internal structure, could fracture the object such that different layers become visible at different locations, could create non-radial exposure patterns if the impact geometry was complex. But getting threefold symmetry from collision requires very specific impact geometry. Requires fracture patterns that just happen to create equal spacing of exposed features, requires that the accident of collision creates organization rather than creating more chaos. Each mechanism has these challenges. Each requires specific circumstances rather than being natural outcome of typical processes. And when you're stacking specific circumstances, when you need formation to create unusual structure, and then fragmentation to preserve it, and then orientation to present it to us in specific way, you're building explanation that's complex and contrived rather than simple and natural. You're describing what conditions would need to be true to produce observed outcome rather than explaining how those conditions actually arise. And even if you accept all the required circumstances, even if you grant that layered structure with threefold symmetry somehow formed, you still need to explain stability. Need to explain why the pattern persists across months of observation, during which sublimation should be eroding the surface and changing which layers are exposed. Need mechanism that maintains the symmetric arrangement rather than allowing random erosion to destroy it. Need either extraordinary coincidence where erosion happens to preserve rather than degrade the pattern, or active process that maintains it. Active process returns you to organized mechanism, returns you to something that operates to preserve structure rather than just passively accepting whatever happens. And if you're invoking active process, if you're requiring mechanism that maintains organization, you've left pure natural explanation behind and moved toward framework where design or control becomes relevant, where the boundary between exotic natural and artificial blurs, because you're describing systems that operate rather than just responding. So the layered structure hypothesis, while creative and while deserving consideration as alternative to artificial origin, doesn't actually resolve the question. Instead reveals how difficult it is to construct purely natural explanation for observed symmetric pattern. Shows that you need to invoke increasingly specific and questionable assumptions to make natural framework work. Shows that the explanation becomes more complex than just accepting that the pattern reflects deliberate design. The rotation dynamics provide additional constraint on possible explanations. Because the jets create forces, create thrust that affects how the object moves and how it rotates, and those forces need to balance in specific ways to produce the stable rotation we observe. Random jets pointing in random directions with random intensities wouldn't naturally create stable rotation, would create chaotic tumbling as asymmetric forces applied torques that changed the spin state unpredictably. But 3I Atlas rotates stably, shows 16-hour period that's been measured consistently across weeks of observation, shows rotation axis that's locked in specific orientation relative to the Sun, shows behavior that indicates forces are balanced, that torques from the jets either cancel or are compensated by other mechanisms, and achieving that balance with random jet arrangement would be coincidental. Would require that the jets just happen to be positioned and oriented such that their combined effect produces stable rotation rather than chaos. 3 symmetric jets with controlled intensities could easily produce stable rotation, could be operated such that their combined thrust and torque creates desired rotational state, could be modulated to maintain specific orientation, could serve as attitude control system that stabilizes rotation rather than destabilizing it. This is straightforward spacecraft dynamics, is exactly how control systems operate to maintain desired orientation against perturbations, so the rotation stability is consistent with and actually supports the interpretation that the symmetric jets are components of engineered control system, makes that explanation more complete, makes it account for multiple observations simultaneously, rather than just explaining jet geometry in isolation. While the rotation stability is difficult to explain under natural hypothesis, where random jets shouldn't naturally create the observed balance, the observational strategy for testing the symmetric jet hypothesis should focus on measurements that distinguish between natural and engineered explanations, should target observations that make different predictions under competing scenarios, should seek evidence that might definitively resolve ambiguity, rather than just accumulating more documentation of the pattern we've already established exists. Spectroscopy of the jets is critical priority. Measuring composition tells you what's being ejected. Natural sublimation jets should show volatiles that are present in cometary ice. Water, carbon dioxide, carbon monoxide, methane. The standard suite of species that condense in cold environments, and that sublimate when heated. Engineered propulsion might show those same species if using naturally occurring ices as propellant, or might show different composition if using manufactured propellants, or if exhaust includes products from chemical or nuclear processes. Velocity measurements distinguish thermal from non-thermal ejection. Natural sublimation produces gas at thermal speeds determined by temperature and molecular mass. Hundreds of meters per second for CO2 at comet surface temperatures. Engineered propulsion can achieve higher velocities through acceleration mechanisms. Kilometers per second for chemical rockets. Tens of kilometers per second for ion drives. Measuring jet velocities and comparing to thermal predictions tests whether natural sublimation can account for observed flows or whether higher speeds indicate propulsion. Temporal monitoring reveals operational patterns. Natural jets vary with illumination and rotation according to predictable relationships. Brightness should correlate with which regions face sun. Changes should follow rotation period. Patterns should be explicable through passive response to external heating. Engineered thrusters might show different patterns, might modulate according to operational requirements rather than illumination, might show correlations with trajectory changes indicating thrust is being applied for navigation rather than resulting from random outgassing. Polarimetry provides information about particle properties in the jets. Natural dust from fragmentation shows specific polarization signatures determined by particle size distribution and composition. Manufactured particles or particles from controlled ejection might show different characteristics, might have more uniform sizes, might have compositions optimized for specific purposes, might show polarization patterns that indicate organization rather than natural chaos. All of these observations are technically feasible with existing instruments. All could be executed during the remaining months while 3i Atlas is still observable. All would provide data that distinguishes natural from engineered hypotheses in testable ways. The question is whether observation time will be allocated, whether resources will be dedicated to systematic hypothesis testing rather than just opportunistic monitoring, whether the investigation proceeds strategically to answer the questions that matter most, or whether it continues ad hoc collecting whatever data is convenient. The infrastructure for systematic study exists. Hubble continues operating. James Webb is available for spectroscopy. Ground-based telescopes can provide temporal monitoring. Radio arrays can search for communications or for electromagnetic emissions from propulsion systems. The hardware exists to answer the questions if observation programs are designed appropriately and if coordination ensures the right measurements are made at the right times. But coordination requires consensus about priorities, requires agreement that resolving natural versus artificial question is important enough to justify dedicated resources. requires institutional support for hypothesis testing campaigns rather than just for general characterization, and whether that coordination emerges, whether the investigation becomes systematic rather than remaining fragmented across individual researchers pursuing separate questions, depends on leadership that might not materialize if institutions remain reluctant to engage seriously with artificial hypothesis. The public pressure might force that coordination, might create demand for answers that institutions can't ignore, might make systematic investigation unavoidable by demonstrating that people want to know whether we're being visited and whether the symmetric jets are evidence of design. That pressure exists and is growing as more people see the processed images and recognize the organization and ask why natural explanation is being maintained when the pattern looks engineered. And that pressure is legitimate. This is public's investigation too, is discovery that affects everyone if it confirms we're not alone, is question that deserves answers rather than evasion, is evidence that should be examined rigorously, with results communicated transparently regardless of what those results show. The symmetric jets are creating that pressure, are making the question unavoidable, are forcing institutions to either investigate properly or to explain why they're choosing not to.